Good evening and welcome back to my class. In this video, we are going to be talking about mathematical modeling, biomathematics in particular. So the question here said that the following model was proposed for the evolution of an epidemic, and we are given these equations that the x over the t is equal to minus kxy and the y over the t is equal to kxy minus ly. Okay, and then the z over the t is equal to ly. They now say that the population is divided into three classes. The first class is that x of t is equal to the number of healthy people. That's the susceptible people. Okay, people that are exposed to the disease. So the next one is that y of x are number of sick people. Okay, then z of x are number of dead people. They now say that k and l are all positive. Okay, that k and l are all positive. Then I say briefly discuss the evolution with a sketch and show that x of t plus y of t plus z of t is equal to n, where n is a constant. Okay, so now we know that from the equation we are given, if we want to do the diagram, we have that is from x, x is those that are healthy. From being healthy, the next thing, the person will become sick. From become sick, the person will die. So they didn't talk about recovery here. Okay, so and if you look at the equation, the change there I have that here will be minus k kxy, and then this side will now be the other side lo. This side will now be ly. Yeah, this side will now be ly. Okay, so now we now want to show. Okay, we now want to show that what are we to show? Okay, we now want to show that x of t plus y of t plus z of t is equal to n, where n is a constant. Okay, so now to show that, now remember that they say that n is a constant, and if n is a constant, that means that if n is a constant, it means that the n, the t will be equal to 0, because the differentiation of a constant is equal to 0. Is that not true? Yeah, that is true. So now, but we know that the n, the t is equal to, from here, from what we are given, from this place, we know that that the n, we are given that x plus y plus z is equal to n. That's what we want to show. Then we should see that the n dt, should be equal to what? The x dt plus the y dt plus the z dt. Okay. Now, if we now substitute this, now let us substitute this, or rather, if you don't even want to start from here, now let us see from what we have here. Let us add everything here. Let us add these three people and see what we are going to have. We want to see what the x dt, okay, the x dt plus the y dt plus the z dt. Let's see what these three things are going to give us. This will be equal to, the x dt gave us minus kxy from what I have here, plus the y dt gave us kxy minus ly, plus the last one ly. Now, if you add all these things, you see that this and this are negative out, this and this are negative. So I'm getting that this is 0. So this implies that the y ds plus this is equal to what? 0. And you see that 0, we got that 0 is equal to this. So that means that this implies that the x over the t plus the y over the t plus the z over the t, sorry, this is the t, is equal to, so 0, we can represent 0 with what? The n over what? The t. Okay. Now, according to our normal differentiation, I don't know where to clean. Permit me to clean up this place. According to our normal differentiation, since all of them are derivative of t, I can have that d of the t of x plus y plus z, okay, is equal to the n over the t. So if this now take care of this, we will now see that x plus y plus z is equal to n. Proved, and very, very simple. So you can write it the way they wrote their own, that x of t plus y of t plus z of t is equal to what? N. So that is proof for number 1 question, number A question. Now, number B question said that we should do what? The number B question said that, okay, they said that we should interpret it. The interpretation is that the total population is concised. Yes, that the total population is concised. That is, individuals only move from from healthy to sick, and from sick to death, no recovery. If you look at this, you see that all of them are addition. So you see that this is concise. They just move from being healthy to being sick, and from being sick to what? To death. So that is that. If you see the way I drew that, you will see that that is exactly how it is. So this is a concised population, okay? The total population, which is N. I hope you know that N is the total population. So this total population is concise. That is, they move from being sick, from being healthy to being sick, and from being sick to what? To dying. So none of them is recovering according to the model here. So now let's move to the second question. And the second question said that we should use the y dt and the z dt equation to show that x of t is equal to x naught e raised to power minus k z of t all over n. Okay, now from what they asked us to use, let's see what they asked us to use. They say we should use the x dt, and the x dt is certain as minus k xy. Okay, and then they equally say that we should use the z dt, which is equal to what? Ly. Okay, now having this, now we're going to see that having these two things, now we're going to see, now let us write the x in terms of z. Okay, let us write x in terms of z, because we are having that x is equal to, so x here, look at this, x here is the dependent variable, y z here is the independent variable. So we need to write x in terms of z. So we have that the x, the z, keeping x on top means that x is the dependent, y z is the independent. The same thing here, x here is the dependent depending on z here. So whatever happened to z here is what will affect x here. So let us write it in this form. And to write it in this form is very simple. Remember that x already is depending on t. So we have the x, the what? The t, okay, the x, the t, multiplied by the t, the z. So that if the t cancel the t, I am getting back my the x, the z. Okay, it's very, very simple. So now, and if you see that, this is equal to, this one gave us minus kxy is being multiplied by the inverse of this will now be the t, the z, and the t, the z is still the inverse of this one. So turn this one around and turn this one around, I have 1 over ly. So I multiply by 1 over what? Ly. So therefore, the x, the z will now be equal to, if y take care of y, I'm having minus kx over what? Over L, right? Minus kx over L. Now this is variable separable, so let us separate it. This is separable, so if you, let me write it as k over Lx. If I separate it, I'm going to have the x all over x will now be minus k over L dz. Okay, so now let us take the integral of both sides. Integral of 1 over x, the x, will now be the integral of minus k over L dz. Okay, so having this now, we will now see that the integral of 1 over x is the same thing as ln x. Okay, is equal to, the integral of this is just to integrate z, which is minus k over Lz. Now, if ln take exponential of both sides, or if ln cross to the other side, it becomes exponential. So therefore, my x will now be, okay, plus a constant, because you introduce the integral constant. So this going here, I'm going to have that this is exponential minus k z over L plus c. If I separate it according to indices, it's going to be that x is equal to exponential minus kz over L multiplied by exponential c. And the exponential of a constant is a constant, so therefore x is equal to what? X naught exponential minus kz over L. Proved according to what they asked us to prove. So question number C, you can write this, you can pause the video and write this before you continue. Okay, now for question number C, So for question number C, they say we should verify that the x dt is equal to L into n minus z minus x naught. Now, we know that n is set as saying x plus y plus z, if you remember. Now, let us make x subject of the formula. Want to make is it x? Okay, let us make y subject of the formula. If you make y subject of the formula, I'm going to have that y is something as saying n minus z minus x. And then if you remember that I've gotten that x, we proved that x is equal to this man. So therefore my y is something as saying n minus z minus this thing we proved minus x naught exponential minus k z all over L. Okay, so now, and the x dt, if you look at this, the x dt is equal to what? Minus kxy. So let me now put the y that I already have. You will now see that okay. Sorry, I think there is a mistake there. Okay, this is y, not x. The y dt. Yes, please, this is y, not x. The y dt. So we are using the y dt. Sorry, that's a mistake. So now dy dt, from here they gave us that dy dt is equal to, is it dy dt? Let me check my question, please. I think I'm making mistakes somewhere. Let's check, please. 1 minute for me to check my question. Sorry. Okay, sorry. They said the z, yes, this is the z dt, sorry. That the z dt is equal to this. So we are using the z dt. The z dt. And from the equation, the z dt is simple as what? Ly. So which is what? L into, look at my y. My y is n minus z minus x naught exponential minus kz over L. As simple as that. Proved. So now question number D. There is question number D, but due to my board is short, so I couldn't write that. So permit me to clean this side and then write question number D and then question number E. So for question number D said we should using analytical argument, comma, how many fixed points does the above equation have, and determine the stability of the fixed points. Okay, and then what does the mean physical, what does this mean physically? What does this mean physically as far as the evolution of the number of dead people? Okay, so in question number D, okay, let me quickly write question number E so that we can solve everything at once. Then I say question number E, what type of system is depicted by the evolution, and what is the force of infection? Okay, so now let us calculate our question number D. So let me to clean all this place because that is a kind of big. Now, for us to calculate the fixed point, you should remember that from what I told you in my previous video, you can check it, that at fixed point, that the derivative of t, the derivative with respect to t is always 0, okay? So you tell them that at critical point, is it critical or fixed point? You can use critical or fixed point, anyone you like, okay? So but they say fixed point. So at fixed point, comma, the derivatives with respect to t is 0. Okay? So what does it mean? It means that the x dt is equal to 0 and the y dt is equal to 0 and the z dt is equal to 0. So to find the critical point now, since this is 0, equate this one to 0. So the first one is that minus kx from here, minus ksy is equal to 0, which shows that x is equal to 0 here and y is equal to 0. Okay, from this one now, we will see that that kxy minus ly is equal to 0. If you factorize y in common, y in bracket of kx minus l is equal to 0. So we are now having that y is equal to 0 and kx minus l is equal to 0 to show that what are we showing? To show that kx is equal to l and then x is equal to what? L over k. Okay, so the next one is that ly is equal to what? 0, to show that y is equal to what? 0 as well. Okay, so the critical point we have here, now if you look at this very well, you see that all these things are in terms of y and z, y and x, because the reason is because that z is dependent. Okay, z is dependent on y. That is why all these things are in x and y coordinates. But if you want to get the critical point in terms of x and z, for me, the critical point here is when x is 0, x comma y will be equal to 0 comma 0. The first one. The second one, 0 and L comma K. This is the second one for me. Okay? So now, but if you want to make it into 3, you should now remember that n is equal to x plus y plus z. So if you put your 0 z here to get your z for the first critical point, you now have that n is equal to 0 plus z. To have that z is equal to n. So the first critical point of x, comma y and z is equal to 0, 0 and n. Okay? Then for this place, if you do the same thing again, that x plus y plus z is equal to n, you get that L over K plus 0 plus z is equal to n. So my z will now be n minus L over K. So you now have that the second critical point is that s comma y comma z then is equal to what? 0 comma L over K comma n minus L over K. Okay, so that is that for the critical point. So what else did they say we should calculate? That we should calculate the stability. Now, for you to calculate stability, the first thing that should come to your mind is what? Engine value and engine vector. So now, use Jacobian. The first thing is to use Jacobian. So using Jacobian, please, I'm going to keep our critical point because that is what will help us. And then the critical point I'm calculating is just for x and y because z is dependent. Is dependent. So the critical point I'm using is just x and y. So that's the only critical point I'm using, please. Let's use just x and y because z is just dependent. So the critical point I'm using here is just for x and y. Okay, so let's get our Jacobian. Jacobian is now equal to, you know the formula now. The formula for Jacobian is that you go column before you move row. So you say partial over partial x. You come here again, partial, you know it's a matrix now. A matrix. So partial over partial x again. You go to this side, it's now be partial over partial y, partial over partial y. Then I've moved column. The next thing to move is now to move row. You pick this one now. You pick this one. the x over the t. Okay, we are moving roll. So the x over the t. Let's move column now using the next one. The y over the t, and then the y over the t. Okay, so this thing is equal to, let us do that. That means we are differentiating this man with respect to x. And if we differentiate it with respect to x, we are having just minus ky. So for this side is minus ky. Okay, so the next one. So let's go again. We are differentiating the same thing again with respect to y. If we differentiate it with respect to y, I'm having minus kx. So here is minus kx. We now come to the second one. We are differentiating the second one with respect to x. If we differentiate it with respect to x, I'm having just ky, because this side is now 0. So I'm having ky. Now we differentiate it with respect to y. If we differentiate it with respect to y, I'm having kx minus l. Kx minus l. Okay? So the next thing we're going to have now, so we have gotten that now. This is our Jacobian. Now the next thing you're going to do is to get the Jacobian around each critical point. That is the engine value around each critical point. So, sorry. For the first critical point, we have 0 and 0 and 0 and k minus n. Okay, let me write this somewhere here. 0, 0, 0, k minus over l. I'll be l over k. Please, okay, if this is if it's 0 and I'm making x subject, l over k. Okay, it's l over k. So l over k. So these are our two critical points. Now, so for the first one, j of 0, 0, that means anywhere we see x, we put 0. And anywhere we see y, in fact, here should be j of x, y. Okay, this is j of s, y. And this is j. So anywhere we see s, we put 0. Anywhere we see y, we put 0. So if we do that, we're going to have that this is 0 times this is 0, 0 times this is 0, 0 times this is 0, 0 times this one is 0. So I'm left with minus L here. Okay? So if we get the engine value, that is the determinant of J minus lambda identity matrix, which will give you, just if you do it short form, you are going to get 0 minus lambda. Just put minus lambda on the diagonal. You have 0 here, 0, then minus L minus lambda. Okay? So if we get the determinant, so the determinant is going to be the determinant. Okay, let me change it to determinant. Determinant is going to be equal to 0. I hope you know. So, and the determinant of this will now be cross multiplied. This time is I'm going to have minus lambda in bracket of minus L minus lambda is equal to 0. So this shows that minus lambda is equal to 0, or minus L minus lambda is equal to 0. So finally, I'm having that lambda is equal to 0, or lambda is equal to minus L. Now, from this point now, you are going to see that the conclusion is that one of these, for the first critical point, that one of these is 0. And since one of these is 0, we say that one engine value is 0, then we call it non-hyperbolic. Okay? And the other one is negative. So the system is marginally stable. You know that what we need is negative and negative for we to conclude that it is what? It is stable. So since this one is 0, we say that it is what? We say that it is a non-hyperbolic system. Why this one is what? Is they call it that it is what is it called? Marginally stable. So they now told us that, but so that we need, they now said that we need more analysis to conclude this defect. Okay, this, hello, please, 1 minute. Okay, so since this one is 0 and we need negative for it to be stable, so that is that. So let's calculate for the second one. Hello, I'm in class. Open the door now. Okay, I'm coming. So let's now calculate the that's the last thing I'm going to do. Let us calculate for the second point, that is for this second one. So to calculate for this second one is very easy. Let's do it sharp, please. For this second one, I have j of 0 and L over K is the same thing. So anywhere we see X, we put 0. Anywhere we see Y, we put L over K. And then if I put L over K here, K will cancel K. So I'm having only minus L here. Okay. So if I have only minus L here, so the next thing I'm going to have is, right? Yes, have only minus L here. Then here I'm having 0 here. Then here I'm having L here. And then here I'm having minus L. Right? I hope it's correct. Okay? So what do we have now left? Okay, sorry. It was K. It was L over K comma 0, please. It was L over K comma 0. Not so that is J of L over K comma 0, which will give you that X. Anywhere you see X, you put L over K, and anywhere you see Y, you put 0. So if I put 0 here, here becomes 0. If I put L over K here becomes minus L. Put 0 here becomes 0. Put this here becomes L. L minus L is giving us 0. So we are left with this. Okay. So the J minus lambda, that is to get the engine value. Lambda this will now give you, okay, the determinant. Let's put the determinant. The determinant will now be equal to just determinant of, just put lambda here. 0 minus lambda minus L, 0, 0 minus lambda. So if you cross multiply, you are going to see that this and this and this and this. So I'm having that lambda squared is equal to 0. So therefore lambda 1 is 0 and lambda 2 is 0. So since the both of them is 0, it is not stable. It is not stable. So for the last question, please, you can answer it for me. They say, what type of system is depleted by the evolution, and what is the force of infection? Please tell me that in the comment section, and I'll appreciate that. So please, thank you very much for watching. Please don't forget to like this video, share and subscribe to your friends. May the peace of the Lord be with you. Bye-bye.